Morning, grade 11s. Sorry I couldn't be there with you today. I've made a little video for us to go over, I would say, the two most challenging problems we've seen up to this point, and we've seen them mostly in our homework assignments. So this is for the benefit of those of us that, perhaps haven't done their homework for whatever crazy reason that would be. So we're going to go over these two challenging examples, and then the rest of the time today is just a review period. So let's get started. It says let h equal this equation, and it's the height of a pump, where the height is in meters and t is the time in seconds. What is the height after 2 minutes? Since it is asking for the time in seconds in the equation, this would convert to saying 120 seconds. So into our equation, we substitute the value in for t to be 120. H is negative 2 times the sine of 120 minus 75 plus 15. I simplify this a little bit further. Negative 2 sine. Inside the bracket, it will now be 45 plus 15. I'm also going to move over here. We recall that the sine of 45 is root 2 over 2. Plus 15. On the left, we have some cancellation, and I'll leave my example like this. This value is exact if the question specifies exact. If it doesn't specify exact, we can evaluate this, and it's about 13.6. This is more of our useful answer since it is more meaningful in this scenario. So it says, what is the height after that many minutes? It is 13.6 meters tall, or meters high of the pump. When the question is asking when, so finding the time, it reaches the maximum height. Remember that maximum height occurs when we're at our midline, which is 15, and we go up the amplitude, which is 2. Now that I know my maximum is 17, I set my equation, my height, equal to 17, and the entire goal now is to solve for the t inside the bracket. So this is an algebraic approach to solving for a specific height. First thing, I'm going to subtract 15 from both sides. I'm left with 2 equals negative 2 sine of x, or in this case, t minus 75. I divide both sides by negative 2. I'm left with negative 1 sine of t minus 75. And for me, this is where I'm thinking, okay, I need to get t minus 75 on its own, so I inverse sine of 1. If this is a step that you're like, I really don't like that, you can always think of it like this. Negative 1 equals sine of theta. So what value makes theta negative 1? That's going to be at 270 degrees. If you did that with your calculator on this side as well, you'd also be left with 270 degrees as t minus 5. The only difference is, since I've converted this into theta, we just need to change it back, and that gets us back into this equation here. Finally, we add 75 to both sides, so t equals 345, in this case, seconds. So when does it reach its maximum height? After 345 seconds. You could convert that to minutes if you like, but I don't feel like it, so we're going to leave it there. The question doesn't specify, so we'll go with the easiest unit. If you need to take a second and pause the video, feel free, and if not, move on to question C with me. Again, it's asking when, so same question, does it reach a height of 16.5? If you want to set this up without any of my help, feel free to pause the video and then scroll through after. But we set our height equal to 16.5, and we go through the same motions. We subtract 15 from both sides. I divide both sides by negative 2. 1.5 over negative 2 is negative 0.75. And now what is really nice about this is another calculator question. I'm trying to get t minus 75 on its own. So I inverse sine of that negative 0.75. That value, according to my calculator, is negative 48.6. I add again 75 degrees or 75 units to get them all back on the same side so I can solve for c, and I'm left and I'm left with 26.4 seconds. So every time I'm doing this with question B and C, I set my height equal, and the whole goal is to get t by itself. These are two common extension questions on evaluations. Hint, hint, nudge, nudge. We're going to look at one more example before I sign off today, and you have the rest of class to prep your work. In this example, it says we're talking about water in a bay according to a cosine function. Notice it's cosine function here, but what's great is they've actually given me the period. T is specifically the time for the hours after midnight. It tells me that the day begins with a high tide of 2.3. So I'm just going to make a little picture here. So at 2.3, that's the maximum. And that happens at 1:30. We'll deal with this in a second. This will be our phase shift when we're starting our function. The low tide is 0.1. Since the low tide is 0.1, the middle of those two values between 0.1 and 2.3 is 1.2. This is my midline. If I were looking at going above and below this, I'm going 1.1 units as my amplitude. So let's start by creating an equation. The height would be the amplitude, 1.1, times the cosine. The brackets already tell me the tide is 30. I'm going to leave my phase shift here for a second, and we add our midline as 1.2 on the outside. Now, to get that phase shift, I'm going back to 1:30. Since it is hours after midnight, 1:30 in the morning is 1.5 hours after midnight. So that's where that info is coming from. Hours after midnight, 1.5 here. Now that I have this equation, we're going to talk a little bit and change this question and say, for this, again, at what time does the researcher have to conduct his study if he needs to be able to conduct the study if it is less than 0.5. So we set our height equal to 0.5 to find the first time where our researcher is able to conduct his survey. Again, the same thing is true. We subtract 1.2 from both sides, giving us negative 0.7. We are going to divide in the next line by 1.1. That leaves me with 0.64 times the cosine of 30 t minus 1.5. To get the 30 times t minus 1.5, same as before, I inverse cosine on my calculator of the left-hand side, and I'm left with 129.7. At this point, I divide both sides of my equation by 30 to leave me with 4.3. And when I'm adding 1.5 to isolate for t, I'm left with 5.83 seconds. So at 5.83 seconds, the height of the water is at 0.5. So therefore, after 5.83, oh no, it's not seconds. If you didn't catch that in the question, it is in hours. So basically, at approximately 5.8 hours after midnight, so therefore at approximately 6 a.m., the research can start. Excellent. So like I said, those are two very challenging examples. This is not assigned homework. This is just extra on modeling. If you check your EDSB page, you will see that there are sample unit tests for this unit, and there are also additional trig identity problems. So if you can be practicing those for the rest, please make sure you use your time very effectively. Your unit test is scheduled for Monday. So please take that time. If you have questions, let me know. Thanks for watching. See you guys later.